It takes many billions of years to create a galaxy like the Milky Way galaxy with 100 billion stars, many billions of years old. For the past few decades, the Milky Way and our neighboring Andromeda galaxy have been on a high-speed collision course. Scientists had earlier thought that this collision would take a few billion years, but they were wrong. James Webb has just sent a shocking signal back to Earth telling us that the collision of these two worlds has already begun. Scientists are now raising an alarm and trying to brace for this high-impact intergalactic collision. What form of signal did James Webb send back to us, and what will be the fate of Earth and our Milky Way galaxy when Andromeda hits us? Join us in this video as we explore why James Webb Telescope receives alarming signal from Andromeda galaxy. The Milky Way galaxy is a collection of stars, planets, and constellations in the Virgo supercluster. It is the vast expanse of space housing our planet Earth. The Milky Way galaxy is one of the oldest galaxies in the universe. If you'd want to spot this galaxy, you'd have to look toward the stellar constellation Sagittarius in the night sky. There you can see its galactic center very faintly. However, all the stars you see in the night sky from Earth actually belong to the Milky Way. The Milky Way spins, and its speed of rotation is relatively faster than many other galaxies. This spinning motion causes it to form a spiral disk shape with young stars and stellar objects like our Sun inhabiting the edges of this spiral disk. Initially, scientists knew little about the Milky Way because of the limited scientific instruments available at the time. In fact, no astronomers at the time imagined that there were other galaxies outside of the Milky Way. They all thought the Milky Way contained all the stars in the observable universe. Our understanding of the Milky Way changed completely when the famous astronomer Galileo Galilei came into the picture in the 17th century. Galileo Galilei used an advanced telescope to reveal new details about the Milky Way that other scientists couldn't find. Scientists had previously thought the Milky Way to be nothing but a collection of bands of light surrounding our planet, but Galileo revealed that the Milky Way was a huge collection of stars, planets, and other celestial objects. Galileo also explained that the Milky Way was not at the core or center of the universe as most astronomers had previously thought. His discovery made scientists see the Milky Way in a whole new light, and several theories began to build up afterward. By the early 19th century, Edwin Hubble brought another major discovery to the concept of the Milky Way, thanks to the Hooker telescope. The Hooker telescope was a 100-inch telescope mounted on the Mount Wilson Observatory in California. It was the largest telescope in the world at the time, allowing Hubble to observe the faint patches of light in the deep cosmos that we now know as nebulae. Hubble observed that these nebulae weren't part of the Milky Way but were actually galaxies of their own with just as many stars and planets as the Milky Way. In the course of his exploration, Hubble discovered the Andromeda galaxy, the closest to the Milky Way. Hubble wasn't the first astronomer to spot this galaxy. In fact, as far back as the 10th century, astronomers had found the Andromeda nebulae. But they simply pegged it as a milky cloud up there in space. This vague description was because of the technology available at that time. Down here from Earth, Andromeda looks like a small blurry white cloud. In fact, the first astronomer who spotted Andromeda did so with his naked eye, without any telescope. His name was Aurman al-Sufi from Persia, and he simply described the nebulae as a small cloud. In case you're wondering how possible it is to spot an entire galaxy from Earth with no telescopes, it's possible but only for the Andromeda galaxy due to its close proximity to the Milky Way. You can spot this galaxy in the night sky if you know just where to look. The name Andromeda didn't come until much later in the 19th century. In fact, back in the 17th century, the nebulae was simply referred to as the M31 since astronomers at the time had no idea what it was. Although the name has long since been changed to Andromeda, you'd still find the name M31 mentioned in some space journals. For a long time, scientists had believed that Andromeda was much larger than the Milky Way. This is because, while observing the galaxy from Earth, it seemed so large. It wasn't until high-tech instruments like the James Webb brought a clearer perspective that scientists realized Andromeda isn't much larger than the Milky Way. In fact, thanks to James Webb, scientists realized the Milky Way was much larger in mass than we had thought it to be initially. However, galaxies are immense systems, and they're ever-evolving. This is why scientists find it difficult to agree on a specific mass for a particular galaxy in the cosmos. From stars to planets, dust, and dark matter, everything contributes to a galaxy's mass. And so, even sophisticated observatory instruments like James Webb can't make for an accurate measurement of Andromeda's mass. It can, however, make for a detailed observation of this nearby galaxy in a way scientists could never do before. But how close is the Andromeda to Earth? The Andromeda galaxy is about 2.5 million light-years away. Now, that may seem like a lot of distance, but in reality, Andromeda is actually our next-door neighbor. You see, the massive size of this cosmic phenomenon, in addition to the massive size of our own galaxy, makes all that distance almost of no significance. However, the close proximity of this galaxy to our Milky Way is not the only thing that makes it special. Andromeda and the Milky Way share quite a number of similarities. Although the Milky Way is much older than Andromeda, it is actually just as massive as the Milky Way. The Milky Way was formed soon after the Big Bang about 13 billion years ago. Andromeda, on the other hand, is quite younger, with an age of 10 billion years. However, despite its young age, Andromeda measures 220,000 light-years across, compared to the Milky Way's 100,000 light-years. Scientists have also estimated that Andromeda contains as many as 1 trillion stars, in contrast to our Milky Way's 400 billion stars. But there's something even more amazing that sets this galaxy apart. It's the supermassive black hole it houses at the center. Andromeda's black hole is about 110 million times heavier than our Sun, and it's the active galactic nucleus of Andromeda. As you well know, black holes are superdense regions in space with an extremely strong gravitational pull that sucks in anything in close proximity. When observed with advanced instruments like the James Webb, astronomers realized the active galactic nucleus of Andromeda was emitting lots of light and radiation. Black holes typically emit radiation due to the radius of curvature around them, so a massive one like this should no doubt emit lots of radiation. As for the emitted light, it's all thanks to gases and stars that have been pulled toward the black hole to form what is called an accretion disk. This disk of matter swirls around the black hole and heats up to emit lots of highly luminous light and radiation. Another very interesting feature the Andromeda galaxy has is globular clusters. These are tight groups of stars that you find in a galaxy, usually formed over billions of years. Andromeda has around 400 globular clusters, each with several thousands or even millions of stars. So, in a nutshell, Andromeda has more mass, more stars, and cosmic phenomena, and a mega-active galactic nucleus. If the Andromeda galaxy and the Milky Way were to collide, surely from the looks of things, you'd expect the Milky Way to suffer the most damage. But that's not actually the case. You see, thanks to dark matter, the Milky Way may be just as resistant and powerful during a collision as the Andromeda galaxy. Our Milky Way galaxy is surrounded by a thick, vast cloud of dark matter that measures up to 2 million light-years across. Just so you know, dark matter is the invisible matter that exists in every part of our universe. It's part of the matter that makes up our Milky Way. But scientists could not see it until advanced research brought its existence to light. Other than being invisible, dark matter doesn't absorb, reflect, or emit electromagnetic radiation. The only way astronomers have been able to detect the presence of this material is via the gravitational effects it exerts. However, one thing is sure, dark matter has a strong influence on the universe's evolution, and it equally played an important role in its creation. Scientists have nicknamed this cloud of dark matter surrounding the Milky Way the dark matter halo. Andromeda has a dark matter halo of its own, though it's a lot smaller. Dark matter, just like regular matter, has mass. And so, while the masses of stars and the super black hole may make Andromeda seem like it outweighs the Milky Way, the dark matter halo actually makes for an almost equal weight of the two galaxies. And so, in a colossal battle, it would be hard to say which of these two galaxies would win. It may interest you to know that the Andromeda galaxy has always been involved in such galactic battles. In fact, astronomers believe that Andromeda is not just a single galaxy but a collection of several smaller galaxies merged into one. This is why its diameter is so large. Most of the collisions that occurred during the creation of Andromeda resulted in the explosion of stars and the spreading of huge particles of stardust in the process. About 8 billion years ago, Andromeda swallowed up another galaxy. It did the same thing 100 million years ago. Scientists call this process galactic cannibalism. They believe Andromeda's many globular clusters are all because of its cannibalistic nature. Now, galactic cannibalism may seem horrific, but it's actually how gigantic galaxies form. Even our Milky Way is guilty of galactic cannibalism, having devoured about 12 smaller galaxies in the course of its 13 billion-year existence. And so, you can say it's all part of universal evolution. Scientists have even found 2 small galaxy clouds that the Milky Way will most likely consume in the next few million years. Scientists had previously thought this cannibalistic act by the Milky Way would precede its clash with Andromeda, but now, thanks to data from James Webb, it seems this intergalactic clash would happen much sooner than we thought. You may wonder why this colossal galaxy is crashing into the Milky Way. Well, it's all part of the grand plan of the cosmos, just in the same way these mega clusters crash into smaller ones and consume them. It is inevitable for Andromeda and Milky Way to crash into each other. And so this leaves us with the big question, what will become of our Milky Way galaxy when it clashes with Andromeda? Consider 2 giant disks of light smashing into each other, causing bright flares with a massive release of light particles in every direction. This is how you'd typically imagine the Andromeda and Milky Way galaxies merging. There'll be lots of stars and planetary bodies smashing into each other, leading to explosions and a massive release of gases and stardust, right? Well, not exactly. You see, this is exactly how early astronomers used to picture galactic mergers, but it turns out that it rarely plays out this way. Even in populated galaxies like Andromeda, there's still a lot of relatively empty space, and our Milky Way is no exception. There is quite a decent space between stars and planets. For instance, in our solar system, the distance between Earth and Mars is about 140 million miles, and the distance between Earth and the Sun is about 38 million miles. Similarly, the distance between our Sun and the nearest star in the Milky Way, the Proxima Centauri, is about 25 trillion miles. Now, you'd agree that's a huge amount of space, and if these 2 galaxies clash with each other, there will be little or no collisions. Rather, what will occur will be more of filling in the gaps. Perhaps stars and planetary bodies from Andromeda will fill up voids in our Milky Way, and the Milky Way will do the same to Andromeda. In the end, we may see star formations, solar systems, and other cosmic phenomena passing through each other freely without even touching. However, this intermingling of space entities will upset the balance and formations of these 2 galaxies, which might spark a couple of reactions and rearrangements. For instance, it is expected that at the end of the collision, we might no longer be a spiral galaxy but as an elliptical one. Naturally, spiral galaxies like our Milky Way and Andromeda have a disc-like shape and spiral arms. Elliptical galaxies, on the other hand, have an ellipsoidal shape. They often appear as smooth images when viewed through space instruments. These sorts of galaxies aren't very common and only make for about 10 to 15% of the Virgo supercluster. In fact, scientists believe only 1 in every 10,000 galaxies are ring galaxies. However, they can really grow to become supergiants, which is why scientists predict an elliptical galaxy will be the result when Andromeda merges with the Milky Way. Moreover, Andromeda seems to be making a transition to an elliptical galaxy already, so there's almost a guarantee it will become fully elliptical after colliding with our galaxy. Another change that may occur is the rearrangement of the newly formed galaxy to host a mega black hole at its core, just like Andromeda. However, this time around, the black hole will be a product of several massive black holes merged into one. Just so you know, it's not uncommon to find black holes at the heart of galaxies, especially spiral galaxies like Andromeda and the Milky Way. It is believed that these black holes play a huge role in keeping galaxies together due to the gravitational force they exert. Scientists believe all of this started in the early universe as black holes provided the initial force to create and sustain what we now know as galaxies. But aside from having a mega-sized black hole in the center, what else can we expect from this newly merged galaxy? Well, radiation. You see, several reactions will take place when Andromeda and the Milky Way collide. And the biggest would be from the merging of black holes. The interaction of these black holes could produce severe radiation capable of destroying everything in a radius of 5.879 raised to the power of 14 miles. And this makes you wonder if Earth will survive this galactic clash. Well, no one can tell for sure. You see, our solar system isn't quite located at the center of the Milky Way galaxy. It is located in a region called Orion's Arm, about 27,000 light-years away from the galactic center. That would be about several quadrillions away from the center if you converted it to kilometers. This off-center location gives us an advantage in the incoming collision, but still, there's no guarantee we'll be safe. This is because scientists aren't sure at what angle or speed Andromeda will collide with our own galaxy. Currently, these two galaxies are approaching each other at a speed of about 110 kilometers per second, and there's no telling if things might speed up at the last minute. If it does, then nowhere will be safe, not even our solar system. Moreover, the trajectory is another factor that will greatly determine the degree of impact. Scientists have run several simulations to try and ascertain how this event will occur. Some show the Milky Way being pulled into the center of Andromeda, while others show the Milky Way and Andromeda galaxies merging from side to side. Whichever way it occurs would greatly determine our fate. Remember, our solar system is located at the Orion arm of the Milky Way. And so, if the two galaxies merge from the side, the gravitational effects triggered by the collision of these spiral arms may fling us to some intergalactic void or even pull apart our solar system. This could greatly affect our weather and climate. We may end up with worse temperatures than we have now or even get introduced to new weather patterns. Our ozone layer is another aspect that will likely suffer damage, leading to worse global warming. And let's not forget about the various components found in galaxies: dust, stars, dark matter, heat, and other space objects. All of these will trigger spontaneous reactions which will be greatly catalyzed by gravitational forces in the two galaxies. And so, there will be chaos as stars and planets shift out of orbit, new clusters and superclusters are formed, and gases mix in potentially dangerous ways. As a result, our solar system will be implicated, and we may end up with a toxic atmosphere when radiations and all sorts of gases released from these reactions get to our own small part of the galaxy. We'll undoubtedly suffer the side effects as habitats may get destroyed, allergies and pandemics may arise, and biodiversity may suffer. But things can get worse if the two galaxies collide head-on, center to center. In this scenario, our solar system may end up getting sucked into the mega black hole at the center, and the rest is history. However, there's little chance that things might turn out this way, but in any case, we won't be able to escape the incoming collision or just stand and view it from afar like we do with James Webb. If by some miracle we're able to witness this collision without suffering from it, we will get to see the cosmic light play out before our very eyes in the skies. We might even end up with new constellations and favorite stars to replace old ones like the Betelgeuse. But there's no need to worry because these things take time. The cosmic timescale is by far different from our human timescale. Going by everything we know so far about cosmic evolution, the collision might take several million years to complete. We'll be long gone by then, and it'll be up to our descendants to figure out a way around this collision. The only problem is that James Webb has revealed it's already happening much quicker than scientists predicted, and so we may need to begin now to learn everything we can from this cosmic wonder. Experts are working hard to find a name for this new galaxy. Some names like Milkdromeda have popped up but haven't been confirmed yet. But in any case, scientists at NASA are working hard using simulations and instruments like James Webb to keep tabs on this collision that has already begun. Thank you for watching another episode of Mega Entertainment. While you are still here, click on the video on your screen to see more mind-blowing videos like this one.